Hello everyone, so I hope we are live, and today we are going to solve today's Leetcode problem. And from today onwards, I was too professional in my streams. Now I'll be quite chill, and we will be having a good discussion. We'll having a relaxed discussion, to be honest, because that wasn't me, the formal me, right? Maybe I'm formal, but not that formal. Okay, guys, so today's question. Let's jump to it. Before that, for the newcomers who, I don't know probably if anyone watches this or not, those who are watching it now or later, so this is a series which I have started and where I solve daily lead code challenges live. This is an unseen attempt. Basically, it is, I haven't solved this problem before. I had solved very little lead code problems when I was basically studying DSA. I was mostly on code forces and geeks for geeks stuff. Okay, so lead code problems are kind of untouched for me, and here I will be solving them. So this is the 873, and the good part is that I have forgotten the more like grip on my DSS. So basically, I'll be attempting things in a most natural way, like so that everyone else gets it, and you can also restore your approach, your strategies, and other things. Alright, enough talk. So there are three steps. First is reading the statement, second is building the algorithm, keeping in mind the constraints we have, and third is converting that to code, and that's it. Then we make submission, and the fourth stage is basically debugging it. So we are not going to leave this problem unless we solve it, right? Because in the last stream, you know what happened? I started at 3 o'clock, but maybe 4 o'clock or 4:30 o'clock, but it exceeded the time limit for that day. It was like 5 hours, and it was like 5:30 was there. Then after that the problem resets, right? So I had to use a time capsule, but that was a good use of time capsule because that was justified because I had started it previously. Okay, anyways, let's go ahead and solve the problem in my iPad. Cool. So as you can see, we have I have already created a notebook for this. You see, this is the same problem you have seen here, right? This is the same problem which I have taken a snapshot of it. Cool. Let's go ahead and read this problem. Okay. So this is length of the longest Fibonacci sequence. Okay. I hope all of us know Fibonacci sequence, right? Some of us call it Fibonacci or somewhat like that. I call it Fibonacci. And to be honest, those who don't know about it, it is written here what is a Fibonacci sequence. But the question is about length of longest Fibonacci sequence. Longest Fibonacci sequence. Subsequence. Subsequence is there. Let's see what it is. A sequence this is called Fibonacci if n is greater than or equal to 3. There are at least 3 terms, and yeah, the next term is the sum of the previous 2 terms. The I plus 2th term is the sum of I plus 1 and ith term. I plus 1th and I plus ith term, right? Given a strictly increasing array ARR, so we have been given a strictly increasing array ARR which has positive integers forming a sequence. Okay, the array has positive integers. Return the length of the longest Fibonacci-like subsequence of ARR. Okay, so Fibonacci dash like is the term what they use. So we have to return the length, not the subsequence itself, just the length of the longest Fibonacci like subsequence. Cool. If it does not exist, return 0. If it does not exist, return 0. So basically we have to find three terms, right? If we cannot find three terms, then probably it's not the thing. Right. A subsequence. Now some of you don't know what is a subsequence. For that there is a definition. Subsequence is derived from another sequence ARR. So ARR is a sequence by deleting any number of elements, right, from ARR without changing the order of remaining elements. So basically we can pick uh, any random number of elements here, and that will be the subsequence in order, obviously in order, right? Cool. So now what is the next thing? Next thing is about reading the test cases. So you got it. Basically we have to find the longest subsequence, which is a Fibonacci. Cool. I think it is not a big deal, man. I mean, understanding the question is not a big deal. Obviously, how we do it, it is going to be scary to some extent. But going, let's see it. This is the example which we have. And here we have this. Right. So if we start from 1, 1 plus 2 is 3. This is a Fibonacci. Then 3 plus 2 is 5. 5 plus 3 is 8. Wow. We have all the numbers which we need. So we got 1, 2, 3, 5, 8. And luckily it is the longest. Yeah, but guys, notice this. Actually, the solution is already coming into my mind. Obviously, it's kind of blurry, but we need to solve it. But yeah, I get it. Basically, there is one thing, like this Fibonacci sequence depends on, like the next element depends on two numbers here, right? The previous two numbers. Okay, so what I wanted to say, if two numbers in a sequence, let's say there are two Fibonacci sequence, this is number 1, this is number 2. If at any point of time these two numbers match anywhere in this subsequence, so whatever is next to this and whatever is next to this, they are identical, exactly identical, right? So in this way we can do some caching, we can apply some DP. You get my point? That was why I was a bit happy, because this part and this part, these are common to each other, right? Yes, they are. Okay, okay, cool. So now we have to do this. We have to formulate our approaches, right? Basically, this was the core thing which I realized. I write it in the next page. What was the first? So this entire page is for algorithm step, which is step 2. First thing first, this thing. I write it in this way only. There is some other sequence which has the same thing. So these two and these two are identical. So length of this hashtag 2's is equal to length of hashtag 1's. So these two numbers uniquely define this guy, and these two numbers uniquely define this guy. Cool. And then then we get it, like, right? So we have to do something here. Now let's read the problem first because we haven't read it yet. This is the second example, and the output is 3. In this case, the longest subsequence is the Fibonacci, like, which is Fibonacci, like, is this. Do we get something? So you see here, 11 is kind of repeating here and here, but you know that this is not identical because this number over here is different. Same goes here as well. Okay. Okay, guys, I'm just texting to someone. Cool. Right. It was an emergency text. I think we all know what is an emergency text. Alright, so cool. Then we need to come up with approach now. Perfect. So I think I'm done with the, if I told you the approach which I derived from this guy is this. Since this is an array, I have to form the elements which are like in sequence, the doubles, the couples, whatever you say, which are in sequence, which are in order, right? Like this, they're in order. Yeah, there are a lot of things, to be honest, we have to think about it. And then we have to do something which is different, right? Because you see, this order is cool, but I noticed one more thing here. What if there are multiple such instances? That will not alter the, like, let's say here it was 3 and 7. So whatever answer we get for 3 and 7, and if we spot 3 and 7 here somewhere at the end, we might not get that answer. Fair enough. Because there might be the case like there are no more. Okay, here comes the constraint of the problem. See, guys, this is the constraint which we talked in the beginning. It is a strictly increasing array. So there is no chance that if we had got 3 7 over here, we'll get 3 7 at the end. No chance. So what we can do in this case? This is a good observation, but I don't think it might be applicable to us or not. Okay, so what are the constraints here? The values itself can go up to 10 to the power 9. So forget it doing with the values because they're clearly not making sense here. 10 to the power 9 is so used. Well, the numbers are positive. Right, now let's come to the real logic. So if I talk about the real brute force solution, which is basically these are the elements of the array. So we create all the subsequences. So we create all the subsequences, and which is like NC1 plus, if we do 2 by 2 things, which is like, I'm not sure if it is actually NC2, it could be anything else, but we gotta solve this problem, man. We have to solve this problem. Okay, so let me think of it. So the problem here is ऐसा हो रहा है यहाँ पे, because so if we go the brute force way, you know that this is going to be in the order of 2 to the power n, which is 2 to the power 1000, which is 2 to the power 10 to the power 30. Really? Not 30, it is like 10 to the power 10 to the power 100. Wow. Wow. So 2 to the power, yeah, 10 to the power 300 actually, right? Yes. Forget about it, this is not a right solution. So what solution could we have here? Let's say we chose this number and then we go with this number. Let's say it was some number called A, this was some number called B. The next number which we look in this part is the next number which we look in this part uh, is basically this part is A plus B. Okay, if we find A plus B here in this part, it's cool. Now the thing is that hmm, so is it true that if it's a Fibonacci, first two terms decide the fate of all results, right? Because if you have decided the first two terms, the whole sequence is gonna just crawl in. Like if it is there in this or not, we don't care. So bus like we have to be patient here. Okay, so okay, cool. Here we need to do something. um, let's change the color, man. Red is hell scary. We'll go with green. So what logic we drew from that discussion is that first two terms, like these two terms, are identifiers of any Fibonacci series. Cool. So if we have n elements and if we choose two such elements, we get like pairs. We get NC2 will give us all possible pairs. NC2 is basically selecting two guys from there. So yeah, it will be NC2, which is of order n square. And so guys, we have n2 square problems, n2 square things. And what we need to do in this case is basically something which is different. Okay, let me turn off the lights because I have to click a picture. Okay, cool. So you see there, there is this. Okay. I don't know why there's a lot of light in my room today, but let's go. I'll post this picture in my community section. Anyways, let's go ahead and solve this problem. Okay, so uh, 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 hmm. This problem is in my control, I believe. So there are n square such pairs, and they are like kind of unique identifiers, right? There are that many Fibonacci sequences for sure. Now, how many of them have a future? So if we go ahead and do n square into n, basically generating the Fibonacci sequence. Like we pick each of these doublets. I'll call them couples. Couples. I'll call them couples. They are couples. Yeah, they are. Okay, so cool. These two guys, right? So for each of these two guys, we generate the future ones and generate the future ones. वैसे भी कौन ही देखता है मेरी लाइव स्ट्रीम. Cool. So here we have this. Nice. So we will generate the next possible terms and we will check if it is there in the array or not. This is, I think, order one operation only. But this check we have to do for n square pairs. But there is a catch, guys. It won't be n square into n. Why? Because, okay, because, okay, so cool, cool, cool. Don't worry about this. So this is n square cross n. You get this right. Now what I need to do is basically, but this seems like n square cross n because for all of this we'll be doing these kind of checks. Correct? Correct, makes sense to me. Yeah, we have to do some sort of such kind of checks, but there is a limit. There is a numeral limit. There's a numeral limit, I guess. What is the numeral limit? If I say, yeah, because each pair is kind of unique, it will start the sum with the sum of these two folks. And this folk, well, this guy is also a key role player here. Also, depending on the locations, we get very limited options here. So n square n is a cool approach, but let's see how the problem allows, how much the problem allows. This is 10 to the power 3, so we can go up to 10 to the power 6. No more than that. 10 to the power 6 is the, I hope 10 to the power 6 is the ideal answer, but this approach is actually 10 to the power 9. Now if I say how we can optimize it, so let's say there are two numbers in the beginning. For this we do the checks, we generate the Fibonacci numbers. Is it actually goes to that extent? I have to like think about this. This is n, this is n plus, this is n plus 1. This is n plus 1, n plus 2, and I'm just taking an example how largely the number changes, right? So let's say this number is 1 and the highest we can get in this array is 10 to the power 9. So if we keep on generating it, it might not be order n, ladies and gentlemen. It can go quite long. Oops, I think I am puzzled here, but see this is 0 0 0 0 0 0. This is 0 0 0 0 0, not 0, no boss. Okay, I am not using the constraint that this is strictly increasing. Despite that, even if these two guys match, that means that wait a minute. If I write the normal Fibonacci sequence, which starts from 1, 5, 8, 13, 21. If it starts from, so 1 is there, 2 is there, 3 is there, 4 is not there. Then let's take 4 and 8. I think it's not the good thing. Okay. And this will become 35. This will become 5 and 555, and then like that we grow. 10 to the power 9 तक reach करना is like easy. Fibonacci of n can be can be Fibonacci of n is actually cached. I think I need to check the definition of Fibonacci once again. So it doesn't start from like any number. So it can start from any number actually, not just one. Yeah, it is a Fibonacci-like subsequence, not actually Fibonacci. That's why they have used Fibonacci thing. Okay. Cool. And here we have this thing ready with us. How to do this, man? Okay, let's go ahead and check whether we are right. Let's go ahead and check whether we are right. Guys, my audio is not clear, I guess. I think this is being an interruption. Okay, now I think I'm chill, right? Okay, okay, okay. Okay. Nice. Then we have to go ahead and solve this problem. Okay, now I will seriously solve it. Just see how I seriously solve it. This is the array which we have given to us, right? Let's take some example. 1, 2, 3, 5, 8, 11, 15, 19. Any random example, right? So Fibonacci for 1 is like 1. If we make pair it with 2, we will look for 3. If we find 3, then we look for 5. Then we look for 8, and then we look for 13, then we look for 21. This is a pattern, right? This is clearly a pattern. Since this is 10 to the power 9, we know that the two unique numbers can define a Fibonacci sequence. But these two numbers, yeah, in this case they will be same. Like if I find 2 and 5 here, then 5 and 11, like 5 and 7, is only one guy, and this can be as large as 10 to the power 9. So basically there will be n square pairs for sure. You know that, like 10 n square starting points for sure. How we can optimize the other stuff? Basically, how can we get the length? If we know the two places, can we get the length which exists in this particular thing? In the rest part of it, yeah, basically if we get these two unique numbers, what is the answer? Because the answer is unique for each of these, because these numbers are strictly increasing. If we have these two numbers, to be honest, if we have these two numbers, the answer for them is unique, and there would be like, yeah, these are basically indexes, so there would be n square indexes, right? All right, so what we need to do in this case is this. I'll just check when I started this session. How was my voice? Hello everyone, so I hope we are live. This was quite good, man. Now it is very low, very much, what do we say, damaged. Okay, so we have n square over here. You see that this is n square. Now we have to find this particular answer. Now let's do it scratch by scratch. Yes, yes, yes. So if we have these two numbers, then we find the next number. Next number क्या है बेटा? Next number we get something. We check if it is there in the particular array or not. If yes, if it is there in the array, there is a possibility of expansion to the next stages, the next Fibonacci sequence number. If it is a no, it's a end game. If we cannot find 7 in this part, we don't need to go ahead and check for other numbers, right? Right, makes sense to me. Yeah, and the numbers which you spot over here are kind of unique. Let's say for some sequence, we found out 10 numbers. For some other sequence, we find out some 10 numbers. Like that, if we keep finding 10 numbers, then something seriously weird is there. So we have to cache these things as well. Why do we need to cache it? I don't think we need to cache it, because we have been given this. We'll explore the next stages, right? We'll explore the next stages. Cool, we will do that. And I think that will be it. That will be it. Because that can take This is already on n square. This will be overall, I must say, overall. Why overall? Because the thing is that like this number, you got 10 here, you got 10 here, and like if you keep getting 10 for all the folks out there, and then this 10 is of magnitude somewhat like n, so this will anyway become n cube, right? So here, if this particular 10 was kind of unique and very limited, so the solution is really simple, which I get in my mind for the first time, is that basically you generate all the n square pairs and you look for the next guy. You look for the next guy. If this guy is there in the array, take it. If it is there in the array, it will be definitely ahead of this because of the strictly increasing array. If it is no, then you have to stop and report the answer which you have got. Now there can be the case like these two Fibonacci, if we keep generating it, the two guys from here, the future two guys from here are already computed. Yes, this can be the case. And that's where the beauty lies. That's where I can be sure that this is the thing. These are eventually. Someone is outside, guys, and I have to speak this low. But bear with me. Bear with me. Yes, yes, yes. Okay. Okay, so what happened? Like for these two guys, we generated the sequences. We found out many more things. Like this can go, this can go here, this can go here. Let's say we found this number. So the answer of this Fibonacci and the answer of this Fibonacci. So the answer of this Fibonacci is 2 plus the answer of the next Fibonacci, or you can say 1 plus the answer of next Fibonacci, which is these two, right? This Fibonacci. Okay, I got this. Don't worry, I got this. I'll check again if I'm live or not. What happened, bro? Okay, I got this. Don't worry, I got this. I'll check again if I'm live or not. Perfect. We are live. So this is my final code which I'm writing here. So it is essentially a DP, and here we will be talking about indices. Indices ij is the this will return length of the subsequence, which is a Fibonacci like, and which is a Fibonacci like, right? I would call it the length of the sequence, which is Fibonacci like, built from the array. Then we have DP, and we have two more. This is there, right? And how do we compute it? Let me show you. We have to use some sort of uh, recursive approach to do this. So we need to have a frequency map, not frequency map, just to check if that number exists in this particular map or not. So what we'll do, we have this big array here with us. We'll start with this guy, and we make pairs of it. Let's say we make pairs of it with this guy. Then in the next step we made pairs of these two. Likewise we created all the pairs of it. This is a step, this is first iteration for this guy. Next, for this, again similar kind of iteration for this guy as well. For this as well, for this as well, and for this as well, so on, so on, so on. When we start, it will be like 0th index, first index. This is FM. This frequency map is also there. Right. Now we'll process this guy. 01 is there. We calculate next. What is the next? If it exists or not in the array, that will be evident from this FM. If yes, then do this 1 plus recursive thing wala strategy 02 or something like that. Yeah, this will not be a frequency, this will be basically the number and its index if it exists in the array where it exists. If it is a no, then obviously you will end it from here. Return whatever length you have. For this, I think you have got something like return 2 only, because that's the answer of that particular thing. 1 plus 1. Okay, now I have 4 coins. Anyways, here comes the next part. Now we can jump to the code section, and I'll show you how real quick I code things up. Okay, let me show you. Okay, let's come here and solve it. Here we have n defined with us, which is array.size. Perfect. This is fine. This is an utility number which we use many times. Everyone knows that. Next step, what we are going to do, what we gonna do is basically this is a real pain, to be honest. Declare this TP array, which is create a vector of vector n. This will be dp. The size of it will be n, and it will get some more things here. What about assigning it with zero values initially? That is fine actually, we don't need it. DP is cool, yeah. So initially we have to assign it with some value like -1. This is the vector, and now we have to write the. Oh, we also need one more thing here. The map, which is index map, to be honest. C++ की आदत है. What we need to do here is have to do this. Maths of answer. Okay, we need to have a node loop over here. Answer comma. This is a recursive function, but it will be a DP function. Yeah, here we get I, J, I am, ARR. ARR is needed. No, ARR is no longer needed. Yeah, this is it. I think we don't need anything more than this. As simple as that. This is the code, guys. But this is not complete. We have to write this integer recursive function as well. Definitely it should take this guy here. I think I have noticed one mistake, which I'll correct. So here is the map, and we need this guy. Send DP. Okay, so here's the thing, guys. If nothing to worry on this part. There's just one check over here, which is the. By the way, we do need this ARR. If if im dot find ARR of I plus ARR of J, and it is not equal to im dot end, it means we found the next Fibonacci guy. Else we do something else. But on top of it, if we found dp of I and dp of j, which is not equal to -1, then we have to return dp of ij. This is there. Here in this case, we have to return 1 plus recursion of AR of J plus AR, sorry. Here we need to pass the index, right? This will be J. The next index will be LP of IM of AR of I plus AR of J. This will give me the index. And then we have IM, then we have DP, then we have RA. Else we have to return 2 in this case because this is the end of the thing, right? Yeah, I think this is the entire code for this problem. If I run it, this is the silliest mistake. I use a keyboard shortcut this time and see how genius I am. It was a one. I think it's too early to comment, but this is, according to me, this is order of n square. Right, n square, mostly n square. Yeah, the big order will be n square for this. Let's see if it works or not. So for the second case, the answer was this guy, like any of these, right? So it took maybe 111 or 311 or 711, whatever. We are doing the max over here, right? Let's go ahead and submit it. If there is an error, we have to debug it. This is the simplest error which one can get. The output is 0. Guys, it starts with 2, man. It starts with 2 because we never return 0 from here. So what happened? 1 plus 3, we got 4. In that case, they must have returned 2. Okay, so it must have the length should be like. This is the silliest mistake. Answer is less than 2, less than 3. 0, else return 2. My bad, this will be answer. What I'm doing here. Right, now it is fine. It will pass like a charm. This is my guarantee it is the correct solution. You see, this is order n squared solution. I think it is n squared. That's why it has passed this problem. Why is it 631 ms? People solving it in less time? How can they do that? If I had to think about it, basically I did the best optimization which I could do. Okay, sorry guys, please beat me with sticks. I don't know, लाठी डंडों से कूट डालो मेरे को because this is a very simple mistake जो मैंने किया है. Okay, this is fine. इसको भी हम ऐसे कर सकते थे. I'll just submit it and you'll see that this complexity rises to what, how the hell it is the same. Yeah, we are using DP, we are caching the things here, but the time complexity was entirely same. डीपी का यूज़ हुआ कि हमने डीपी से वो रिटर्न कर दिया, कैशिंग कैश्ड वैल्यू रिटर्न कर दी. dp of ij is not equal to -1, return dp of ij, वो वाला step. Then we go ahead and check. Right, so order and square तो बनना ही चाहिए कैसे भी करके. That will be the real justice to this problem. I don't think someone has solved it in order. And yeah, this is the editorial of it, which has time complexity of n square log m, which is brute force. Why it is brute force? The brute force was also acceptable for this case. And this will still be order n square, guys. Let me check the complexity. Yeah, it is n square only. Then we have optimized dynamic problem solving, which is again order n square. Yeah, they cannot come up with something which is order n log n or something like that. A variable n to store the length of the input array. Yeah, this was it, man. I have solved it. So this approach is what we had to think of, and it took this long discussion to finally come up with the solution. This was my today's time, ladies and gentlemen. Thank you for watching, and I'll see you in the next one. Till then, goodbye, take care.